Well, good afternoon, everybody. My name is Christine Radke. I'm with FPSA, and thank you so much for joining us today. I just have a few housekeeping items I'd like to go through before I introduce our moderator. At any time during the broadcast, you are welcome to enter your questions into the questions pane on the GoToWebinar sidebar. And then after the webinar, you will also receive an email that will have a link to the recording. You'll get a certificate for attending. And we also have a survey, and I highly encourage you to please complete the survey, as it helps us improve and continue to provide you with the content that you are looking for. One other note, the copy of the presentation and the bios are in the handouts, also on the GoToWebinar pane. Okay, so now is my gratuitous plug for FPSA. We do a lot of stuff here. A lot of our things are done by the networks, just like this webinar. It was organized by the Packaging Network. Some of the programs that we have ongoing and are actually openly looking for volunteers and participants. One is the Mentor Circle. This is a mentorship program that's basically going to be done virtually. The online application is going to open next week, so be on the lookout for those emails. And then also we have a Packaging Network survey that we're trying to collect more information so we can prioritize what topics we want to work on. If you want access to either of those, you can contact our Senior Vice President, Andy Drennan, or just look for some emails in your junk box. As I mentioned, this webinar has been put together by the Packaging Network. In particular, I have to give a shout out to Troy Manley and Glenn Godino. They were very instrumental in coming up with this topic, coming up with the outline and the objectives that we want to give to you today, and also finding our excellent panel of experts. Okay, so with that, I am very pleased to introduce you to our moderator, Kristen Joker. I actually had the pleasure of working with her last year at Process Expo, and she's a great moderator, great questions. Fun fact, she used to be a writer for Vogue, and now she's the editorial director at BNP Media's Packaging Strategies magazine. So I think it's still glamorous. Would you say, Kristen?
Yes, it is. What a personality. Nicer people.
Okay, with that, I'm just going to go ahead and hand it to you, Kristen.
All right, thank you, Christine. Hello, everyone. Welcome to Overcoming Reliability Challenges, a webinar presented by FPSA. Today, we have two industry experts who will be sharing strategic ways on how to improve reliability, redundancy, uptime, serviceability, cost, and throughput. Our first expert is Robert Champion. Robert is an innovative industry leader with 30 years multinational CPG and OEM experience across varied systems, product lines, USA, where he held the position of Group Packaging Equipment Engineering Manager for the US market. There, he was responsible for all packaging, capital invested systems across varied businesses, beverages, and prepared foods, including pizza, baking, ice cream, and culinary professional. He is currently the president of InnoFlex Solutions, LLC. And our next expert is Frank Latino. Frank is an automation expert who's currently a global product manager for electric automation at Festo. He has over 30 years controls experience with roles in development, project, and product management. He has been a project manager and senior control engineer at OEMs in the ASRS and machine tool industries. He is active in social interest groups for ODVA and NFPA. Frank is a specialist in network technology and holds 2 patents in the area of pneumatic valve controls and diagnostics. Thanks so much for being here, both of you. And Robert, we'll start with you. The floor is yours.
Well, Kristen, thank you for the intro. We really appreciate that. I do. And again, thank everyone for joining this webinar. It's going to be insightful. We're going to just start off with a 30,000-foot view, and hopefully we can dive in enough detail to whet your interest. But it's just like the pandemic almost, right? We've been locked up for so long here. We just want to get out and just be able to communicate the message. And there's probably going to be another time we can get into more detail. But essentially what we really want to partner here and talk about is how do we help our consumers and our customers meet their needs? And that's what we're going to focus on right now. So we're going to just get going, and let me make sure I get my slides here. Just bear with me. Should work. There we go. Sorry about that, team. So here we are. If we look at capital investments, let's talk about capital investments.
Robert, sorry to interrupt. We are not seeing your screen yet.
Oh.
Okay, here it is. Got it.
All right. Technical difficulties. We get it. So when we start talking about our customers and consumers and technology, I think we should talk about capital investments. That's on the front end, and we should talk about existing assets. That's essentially the ecosystem of supply and demand in what we do today as far as packaging suppliers and equipment suppliers and food companies. So one of the questions I have right off the bat is, how do we control what we control? Meaning your capital investments, your existing assets. How are we controlling it to ensure high performing systems that are, maybe there's some redundancy on duplicate equipment types. Maybe there's redundancy in a good way on devices on that equipment to ensure uptime. And then uptime and downtime. How do we make sure we have uptime and reduce the downtime? Serviceability and access to those assets. How do we ensure that those assets are readily available to get at and fix and get up and running very well? How do we bring our costs down on those assets? And how do we ensure, again, supply and demand to our consumer and customers? And how do we get efficiency up? And then labor. I mean, labor is huge today, right? If we look at how we operate, a lot of our operations in some facilities use manual labor. Can we offset some labor with some automation? And does it make sense? So how do you control what you control? And I want you to think about that as we go through this. How could you be better in servicing your customer and your consumer? Okay. All right, sorry. There we go. So what I want to do is take a step backwards and look at the industry overall, the last 5 years, all right, greater than 5 years, kind of the norm. Most of you probably know this, but again, if we don't really understand the arena that we're playing in today, how can we understand the new arena going forward in our new future? So if you look at really our audience, it's our food companies and our CPGs are supplying, right? And our manufacturers. They're supplying the equipment and they're supplying the product to our consumers and our customers, the retailers, whether they be e-commerce, brick and mortar stores, whatever that case may be. But if you look on the left side of the slide, I would say that the market for some brands in some industries have been flat and they're mature. The dairy industry, traditionally the food and frozen, but now food and frozen is upticking because of the increased at-home use, need for eating at home. Confections business, right? Who needs chocolate when we're trying to maintain getting beef to people because we have some beef shortages, right? But that's a little joke there. But then materials, right? There's been like standard materials that we've used in the past. There's been less differentiation between, versions of what we call PAC ML, and that's just basically the language that a packaging line uses to communicate between devices, the state of it. And then there's various levels of TPM, total performance management. Like, how do we manage this assets to keep it under control, right? And our consumers, they've been basically at the same time pulling from us. There's been some changing landscape of needs. There's an aging demographics. There's a larger buying segment with millennials. Our packaging formats changed slightly in 5 years, greater than 5 years. And then, packaging waste sustainability, yeah, there's been a little noise about that, but not a whole lot of action, right? That has changed. And we're going to advance now to really what we're looking at today. And what's happening today is it's on the converse, less than 5 years. Acceleration in mature markets are now starting to grow. The frozen industry is growing because, again, the needs are higher. The needs for home use are higher. And then there's been some innovation in the brands. So a lot of these big food companies are innovating on the frozen category, and that's driving some demand. The use of sustainable materials are now impacting the needs, right, of our growth. And that's going to impact the operations on some of the assets, the existing assets and the new assets we would want to deploy. And that simply means, can we run any and everything on those assets, and what are the limitations? And again, how do we control what we control? And this is going to become more important as we move forward. It's going to be very, very paramount. And the key is analytics and data at the production floor, at the machine level. I think this is very important in getting feedback quickly and repeatedly, right? And autonomous and automation. So autonomous vehicles and automation are going to help drive the wave of the future. There are tools that will enable us to do those things I talked about: cost, bring our costs down, being flexible, working in e-commerce from a supplier and a CPG standpoint. And so the consumer is pulling this. Everything we do is about the consumer. There's changing needs, there's changing demographics. Let me give you a case. I have an aging mom who'll be 80 years old. And I just, recently brought her into my home to live with me. And what I found was, when I lived at home as a young adult, right before 21, and then went away to college, got married later, that she's a different woman than what I knew, right? So I visited a lot, but just opening packages, there's less force in her hands to be able to open a simple package today. So we've got to address those demographics and our different geography of people and their changing requirements. Millennials, they're pushing and asking for things in a different format, less packaging waste, less plastic bottles, more recyclable and reusable. And those driving that need. Packaging needs are changing. I will say the other big piece are the requirements inside our operations. If you're a food producer, is you've been asked to make smaller batches, and you've been asked to do more different types of deliveries, supply to the market through whether it's a specialty channel, traditional brick and mortar, direct to home, e-commerce. And how do you do that in your existing assets? And how do you do that with your new capital investments? How do you do that talking to your partner, which is your equipment supplier? Are you two talking together to ensure success and having a view of the landscape before that happens? And one of the big things that I think I like is that there's meat alternatives today, right? So if you are vegan or paleo and you want to, this is growing very fast. And basically, this is just saying that there's some disruption in the marketplace. So if we just look at SKUs and the trends in the industry, keep playing on that last slide, you'll see that, yeah, there's batches of one. So there used to be cases of monolithic cases of quantities of 20, 30. Now maybe there's a mixed pallet on that you're shipping out. And maybe there's, in that case, there's mixed SKUs. So how do you play in that market and be efficient and be supplying to your customer, meeting their needs? We talked about smaller SKUs. That's important. And the big thing I think that's playing in your customer is compressed schedules and cycle times. How are you, or how are we going to compete to ensure demand and supply? And how are we going to deliver that capital equipment on time that meets the needs? And how is this food company going to ensure that product, that asset runs reliably? Do we need two of the same types of equipment because of some abnormalities in the system? And then there's another big piece that we call quality of revenue, which is the playbook that ensures, what companies look at today. So total cost of ownership, TCO. Really, if you started to look at investments today going forward, it's how do we reduce the time and the costs and invest in the right capital investments to ensure that the brand that we invest in is bringing in good revenue. But then there are some renovations that you see out there. And these are just some I took ad hoc off the public domain, but a lot of this is happening. It's what else can we do? And how fast can we pivot to do that with the existing assets that we have and new investments that we need? More importantly, the aggravation that it may cause inside the facility to do that. So again, how do we normalize an abnormal situation? And especially with the acceleration of some things happening. You talk about food development and things that are happening today. I talked about the Awesome Burger, Impossible Burger. I'm not giving kudos to any of the companies, but just to say that there's a lot happening fast. And again, how does this product play on your equipment? How does the material impact the interface of that equipment? So how do we know when it's out of baseline condition? Packaging formats. There's any and everything that's out there that's happening. Recyclable, reuse, reduce. There's different formats of the material, different substrates. You know, how are we ensuring that when this comes into the organization because of a need, that we're able to deliver that with sustainable solutions? Yeah, that are running well, that are not down unplanned, and we keep the uptime. So as you can see, this is just, again, a 30,000 point of view. There's going to be more aggravation happening. How do we normalize abnormal situations? And then again, we talked about the supply chain. You know, we need to be prepared, and some of your customers are going to play more in these supply chains. And a question I have for you all in the audience, think about this. Are you having conversations with your customer and romancing your customer and getting in, understand their business so you can be prepared to be a true partner with them and help them meet their needs to their consumer? That's the question. And, you know, so this leads me to talk about really what I love is digitalization and modes of operation. What are those two things? Modes of operation is the behavior on which that packaging system, processing system is intended, is designed, intent from a hierarchy level. Then you go down to the machine level, bits, devices, connectivity, data out of those devices. And digitalization, for me, as I look and think about this, is an enabler to monitor quickly and change and drive positive results. It's a tool that enables us to make decisions quicker. And that's what your customers are looking for, this quick decisions to make a step change. And if you look at that, it's really, you know, it keeps the norm at norm. Once that norm is true, that's a pun on words. So if the norm isn't true, we're chasing our tail with high MRO costs or higher downtime or higher stoppages or variability in our materials. So we need to get our hands around abnormality to drive it to a normal state. So the data and the AI that we get enables us to take the norm and enables continuous improvement. This should be an ongoing process where we're always driving toward improvement. And as you take a look across the landscape on modes of operation and digitalization, you know, there's a key thing. This is something I took from Deloitte. It's public domain. And it just says basically that factories are, and probably you're facing this, your customer is, if you're a supplier, they're facing, how do I get more out of my existing brownfield operation? Because there's not many new facilities being built. They will expand facilities because of key growth opportunities. But in any case, is how do I get more out of what I have to make the right business investment decisions on those packaging systems? So digitalization and devices allow us to get critical data, again, to transform that factory, make quick decisions, and drive and have a competitive advantage. And that's what everyone's looking for. How can we be different? What's our value proposition? You know, again, this is a 30,000 view, and I'm going to give Frank a chance now, my colleague here, to drive the next. And Frank, you're up.
Thank you, Robert. Thank you. Hello, everyone. Good afternoon. Well, it's a perfect segue, Robert. Thank you. I'd like to talk about digitalization and the impact of the current and future equipment needs. I like to use the definition from ARC because I think it's really nice and simple. And they really talk about, well, digitalization, and that could be what you might call it Industry 4.0, you might call it the Industrial Internet of Things. But it always comes down to this really this internet enabling business improvement strategies. So how do I use internet enabled technologies to improve my business metrics? This could really help manufacturers with a variety of metrics such as OEE, serviceability, costs, a lot of things that Robert had already mentioned. So one important thing about digitalization, it's not just about the operation of the equipment or about maintenance on the equipment. There's a journey that happens when you're investing in, or let's say designing a piece of equipment, investing in some equipment, where you go through stages of the conceptualization, whether that's on a new design equipment or a production line, where you go through design, procurement, and then commissioning, operation, and then post sales, post support, or maintenance. This journey that you go through, digitalization can actually help in every aspect of that journey. It's not just one section of it, and you can jump into this journey at any point. You don't have to go in sequence here. You could actually decide what's best for your equipment and what's best for your customer needs. Next slide, please, Robert. So I just have a couple examples. I have a couple of examples now here, and then we'll get into some other more detail later on in the session. But let's take a look at examples. So the first thing I'd like to touch upon is the idea of digital twin. It's a lot more than what you might think of as just maybe traditional CAD models or some digital information about any device. The idea of a digital twin, there's actually effort going on today that will try to categorize and catalog up to many different data points, actually up to 40,000 data points per any different device or component, where now as a user, you could actually go search for these different components, compare them with other components, and look for the information that you need. I know Robert talked about finding information faster, doing things quicker, and the idea of the digital twin will certainly aid in that. And it's not just used in the design aspect of your equipment, so it's not just that part of the journey, but also in the maintenance and support side of the journey. So as an example, you may have a piece of a broken actuator or something on a piece of equipment, on an asset, and you need to get a replacement for that really quick. You might find that your supplier doesn't have it available. It's the lead time is months away. You need to get something up and running quickly. So searching for data by use of the idea of a digital twin, by having so many data points categorized and being able to search with them, you can go now not just look for, yes, an actuator that might fit the load I need, that has the length I need, the diameter, the forces, etc. But you might find other information should be much easier to be found. For example, something like the B10 value of a device. That embedded data could tell you whether what kind of life expectancy you're going to get out of the device. So if you have to search for a third-party component to get your equipment up and running, you might want to know information like the B10 value of that equipment, or maybe does it have a food grade grease that you might need, or what is the grease? That type of stuff can be embedded digitally and in the idea of a digital twin, and you would be able to really search that and look that up, can make comparisons real quick and get the right part that you need as fast as possible. So that's one example of maintaining serviceability for something with using the idea of digitalization. On the control side of the equipment, there's a lot of common examples that I could give you here. So these are examples that would use maybe digital control more often over mechanical solutions that might have traditionally have used. This would be to improve serviceability, reliability, agility of the equipment, and costs. So for example, robots, AGVs, independent cart technology. These will definitely reduce the amount of mechanical changeover that you need, but also give you that flexibility for meeting the consumer demands in the future, like Robert had discussed. I mean, I could see an example in the future for maybe frozen food manufacturers making custom meals, perhaps, or whatever, lot size one. This type of technology would be pretty necessary, I think, to be able to do that, to digitally change the functionality of a piece of equipment to make customized recipes or whatever for certain people. That's going to be, I think, something to address consumer demands in the future. Other things, for example, smart electric or smart pneumatic controls. So for traditional machines where they might have been mechanical stops, if you would replace that with electronic format setting, for example, with an electric cylinder, you can position that anywhere in the equipment. That'll give you, much quicker changeover than having to use mechanical settings. I'll give you an example, smart pneumatic control. There are many cases where you use a pneumatic cylinder to just simply go as fast as you can to an end stop, and there's a shock absorber that will absorb that energy in that stopping motion. But as that shock wears, you're going to do more damage to the equipment, possibly to the parts that you're carrying. What if you could control that electronically and control the ramp up and the accel and the decel of that actuator and stop real quick? You'll have the same speed and motion, but you won't have that that constant use of a shock absorber. That will extend your life of your equipment and also of your product that you manufacture. And it's also to note that electronic devices at that, when I'm like smart electric cylinders or smart pneumatic control, inherently they come with additional diagnostics, and those diagnostics can help you quite a bit also. If you're out of range, if your actuator is not traveling at the same speed or something, there's a lot of different diagnostics that you can get from equipment like that that will help you troubleshoot problems sooner. And finally, cloud-based systems, using cloud, for example, for maintenance and service of systems. This can, using a cloud can put the information in the hands of multiple service teams. So if you have a large plant, you have multiple teams, they could all share that information. Or if you have plants across the globe that are doing the same type of production, that the maintenance data can also be shared amongst the maintenance teams anywhere in the world. So that now will give them that ability to help each other. Hey, I've seen this problem before. If you saw this problem in the US, you're going to see the same problem in Europe or in Asia. So that will help quite a bit for maintenance teams to get resolve any kind of issues quicker and get going. And it's also that is also important for remote online services as well. You can remote into equipment using this type of equipment, or using a cloud that have other people have access to some information. That will help quite a bit on reducing costs and downtime. So Robert, thank you. You can go to the next slide, and we can go to the Q&A.
Yeah. Great segue, Frank. Great stuff. And we will. I think it's time to take some Q&A. Let's see what our audience has to say.
All right, thank you guys. We do have a couple questions that just came in. Frank, you touched on this a little bit, but we got a question. What are newer technologies that make maintenance easier and can be implemented into existing equipment?
Okay, so well, we might touch on some things later on today in this session. As I mentioned before, with the idea of using internet-enabling technologies for equipment, having an Ethernet infrastructure, I think, is essential in most cases. And most equipment today have, anything that's been done in the past 5 years or so, I'm sure has that. But it's something that can also be added on, overlaid on top of existing equipment if it's not there yet. Some investigation needs to be done, looked into what kind of controls in the system or whatever, but that could be something that could be done. And once you get there, then you could start adding data points that you might need that would help improve serviceability. Because as I will mention later on, you can't fix what you can't measure. So by adding those extra data points, you'll be able to improve that.
Great, thank you. We have another question here. What phase of operations is Uptime seeing the most disruptions?
Let me try that. Frank, you want me to take it or you take it?
Yeah, please, Robert. No, that's all you.
Yeah, well, what I've seen in the industry is unplanned stops, minor stops, changeovers, labor knowledge of baseline conditions. I'm going to say what's important are the inputs to a well-running production line. As I started earlier, we talked about, the higher level at the line sequence of operation. How should it run? Then you drill down to the inputs that are added to the production line: people, materials, product, and these impact unplanned stops. So we want to reduce minor stops to zero. And as Frank said, with technology, we can use those devices to help us strategically locate on that machine where critical points are. We want that knowledge.
Exactly, thank you. I'm seeing some questions come in that are actually going to be covered in our part 2. So if it's all right with you guys, I think we should move on to our next phase and then open it up for these questions after.
Good.
Sounds like a great plan. Yep.
All right, so short break. What we just did was we took a high level overview, and now we're going to drill down to, okay, you said, great, that's pie in the sky. I think Frank went in more detail than I did, but now it's about the nuts and bolts, a little bit more about how this really tied together. So this will be more on the, application. So again, process and packaging system requirements. Again, we look at 5 years, greater than 5 years, start there. There have been big production lines. So if you've walked at any of your customer facilities, you'll say, wow, those lines are large, they're long, and they're producing a lot of pieces per minute. And that was the way it was done. Volume, 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 volume was king, yeah? And remember I talked earlier in the earlier slides, the disruption is, how do I bring in some of this innovation to these lines that are already there asset-wise? And instead of investing multiple millions, I want to reduce it to smaller millions and get more out of those lines quicker. So big production lines, high MRO costs. Some of it is just it's unfavorable. We need to fix that. We need to fix our customers' MRO costs. We need to be a strategic partner with them, with our technology. Redundant equipment. And I've seen in some past, through my career, where there's the same type of equipment on the line just in case that one failed. Or in case we did maintenance, we want to make sure that we can keep running and divert product to that piece of equipment while we did maintenance. Maintenance was more than the planned amount of time, all right? Flow changeovers. Even with pack and mail, I still have seen unplanned stops. Because again, I'm gonna say, you have to look at the basic blocking and tackling. You'll say, oh yeah, I'm an old athlete by heart. So blocking and tackling, that analogy just means, it does us no good to put all these bells and whistles on the machine if we don't have baseline conditions and knowing what baseline is. Remember, we talked about enabling the norm. Once we know what the abnorm is and getting that in the normal conditions, then we add our sensors and devices. So there's been various levels of TPM, smart devices, and some packaging systems and data to the operators. Some of it, not a lot of machine learning. Like, what's the habits of this line? How can we improve our next investment? And I'm putting my food company hat on now. How can I improve my next investment if as Frank said, I don't know what I don't know. So I want to know what's happening. I want to know about the operator behaviors. How many times he or she engages with this machine and what are they doing and why? I want to know about product variability. I want to know about connected equipment that's upstream and downstream that are having issues and really go to the root of the problem. So I want to understand more about the machine. And then I want to give that information, if I'm a good partner, I want to give it back to my OEM and have them help develop their R&D. So it's about a circle, a feedback circle, so everyone can win. And I think that's the opportunity. And accessibility to some parts, man, if you go in some of these machines, good luck, right? They weren't designed for easy access. They were planned to have no breakdowns, but unfortunately, because of the norm being abnormal and new products being added onto that production line that weren't intended, there's been an unbalance of conditions. So we need to get that back into balance. So fast forward, and we look at our new state, what we're going to see is there's a call for smaller production lines. And I'm pausing. I want everyone to think. You say, well, are you nuts? Why? There's some top line reasons. Real quickly, because I want that asset to depreciate quickly. I want to not making up a number $1 million for it. Why not buy something less expensive that gets the job done, that depreciates quicker? As a business person, put your hat on there. And then I may want to repatriate that line. Think about modularization. So a lot of your customers today in brownfield operations want to move a line or basically redeploy it with automation, with autonomous vehicles, with robots, with some of those things, and smaller lines, so they can run different products and packaging formats. Remember I talked about earlier, how can we be more in the different omni-channels, getting more revenue for these companies by giving them more outlets to sell their products? So the better we can do that for them, the better we are as a partner. So, you know, there's redundant equipment. I think there's no need, my personal opinion, this is Robert Champion, I don't think there's a need for redundant equipment if we work on the problem of the issues that we have on existing. Fix the problem, and then you normalize normal and not abnormal. I would only recommend redundant equipment if it's, you know, really a strategic, you know, a strategic SKU changeover that we want to make sure we can keep running and not lose that volume. So I think back, and this is going to cause you to go back to your customer and ask them, how can I be a better partner with you? What can I do in my toolbox to help you not have, you know, all this cost and redundant equipment? And then changeovers, they need to be quick, right? I don't want to go into that, but you know, we don't need arduous changeovers. We need a 5-minute changeover or less. And as Frank was saying, a lot of this today with some of the smart devices, you know, servo motor changeovers, I won't go into a lot of the detail. You can do that at the HMI, right? There's a cost for it, but the cost, that's in my next few slides, the cost is only imperative to the value that your customers see as far as throughput. Will they sell more packages from spending a small amount of money for gaining thousands and millions of more packages to sell to market? And think about the COVID situation. With the supply hindrance was because we were bottlenecked in some facilities because we're only going to get so much out of those lines. You're going to run longer hours to get the same throughput out. We got the product to the customer, but I'm sure if you looked at the balance sheet on what the cost was, it is not favorable. So systems that are usually layered on top of existing control systems, and Frank talked about this. There are some systems that can be layered on top of your existing, your PLC systems and bolt on that can enhance what you have. And this, Frank said, it is a journey. You can grow into it as your business matures, and we learn from what you have to be able to maturely engraft and grow into this. So smart devices, they're out there, right? I think Frank's gonna talk about that. Machine learning. So here's a slide I thought crazy one night. I woke up saying, yeah, what is the real world, right? So it's really straight, right? You produce, you have an end target, and it's done, right? Factory warehouses, wherever you ship to, consumer stores direct to consumers or warehouse, right? Or DCs, but there's an impact to manufacturing to do this. And remember we talked about earlier, supply and demand to your customers. How do we reduce downtime and abnormality, overcoming reliability challenges? Forgive me for stumbling on my words. But the impact is to manufacturing is, as we talked about earlier, just summarizing, we've got all these things continually happening. And you know what a factory looks like that tries to do this today? That's a question for the team. How does a factory look when you walk today when they're trying to do omni-channels, specialty products in their facility or in the bolt-on their warehouse or in some bay inside their factory? What does that look like? How is that from a safety and ergonomic standpoint to that customer? Well, really today, it looks something like this. You say this is like a roller coaster, or actually it is a roller coaster, because what happens is, remember, you have these big long production lines. Now I want to take some volume. I want to be able to turn on a switch and take 10,000 packages off that line to do something in my existing factory. I don't want to ship it to an external co-pack or a co-manufacturer. I want to be nimble. I want to compete with my smaller companies that are out there. I want to be first on shelf and maintain my shelf space. How are we doing that? Well, there's a disruption that I think we need. We talked, as Frank and I talked about earlier, a lot of the technology that's out there. Again, I won't, I'm not giving a lot of credit here to it, but autonomous vehicle, robotics, where it offsets, and enables throughput or solves a problem, whether it's ergonomics or safety, that helps them win, or throughput, right? So that's just some of the noise here. But product development today is, you got to think about the omni-channel. So the conversation should be, wow, Mr. and Mrs. Customer CPG, how can I help you in your goals or what you're trying to achieve? I want to be a selected partner for you. I want to be your only partner you call first. So let me understand your business and your customer that's driving you to do this. Let me understand your business. So I'm going to pass on to Frank now and let Frank drive.
Thank you. Okay. So yeah, like we mentioned earlier on today, and going on there, I want to really talk about two main topics at this point. Now we're getting into the real nuts and bolts of the equipment here. So machine requirements for process and packaging systems. As we mentioned before, you can't fix what you can't measure. You need increased data points in your equipment. And honestly, an Ethernet infrastructure is how I see it today is one of the best ways of doing this. You can increase data points by strategically deploying sensors, use of smart devices, embedded sensors and equipment, and this will get you different condition monitoring information. Yeah, and this all requires a really an appropriate infrastructure. So with Ethernet, you can carry a massive amount of data. It's very high speed. There's a lot of work happening in the area of Ethernet technology, even using some new technologies coming in the future, which will get us a lot more ability and a lot easier to make it for certain data scientists or others to get information from your system. So like I said, there's a lot of standardization work happening, there's a lot of technology work happening, but I think you really need to start off with an Ethernet infrastructure. And then looking at a subnetwork, now IO-Link, I'd like to mention IO-Link. Sometimes it's known as the last meter of the industrial Internet of Things. So why is that? So to deploy those sensors with you could have an Ethernet infrastructure, but now you want to get down to the individual sensors, and there's many different different sensors that you can, or different devices that can connect to an IO-Link. I'll get into a little bit more detail in the next slide. But so that I think is very important for what we're talking about as far as getting this data. The next step is condition monitoring or predictive analytics, and that's going to definitely improve serviceability. So now once you have that Ethernet infrastructure, you can start making use of what's known as an edge device or cloud gateways. And an edge device is just just a smart box. It's a smart controller that might be very compact, embedded, deployed in a very small piece of hardware that might be on the machine that would be able to interface with an operator or interface with the machine directly, monitor certain aspects of the machine, and if there's a problem, if there's an anomaly that's detected, it would immediately inform the operator or stop the machine, so you could halt your production or whatever is necessary to do it at the time. The cloud gateways are important for this because, and this actually gets into the area of machine learning and artificial intelligence, because now with a cloud gateway coupled within this edge device, you may need to have the horsepower of a computer doing some processing for learning trends and of your equipment. So the edge device could do its job by detecting the anomaly. So those calculations might need to be done on a larger, more powerful platform. And that's where the cloud connection could come into, where there might be a connection up to the cloud where some of the major processing is being done on the cloud side of things. And then the edge device is just doing the detection of the equipment, and then the information, and then setting information to either, again, an operator or directly to the controller. So, and then the next step would be also cloud gateways also for dashboards. So I see many customers going in the direction of adopting a dashboards where they could view a lot of information from the machine or different components of the machine in one setting. These dashboards can be configured to inform people of certain limits that are being reached by the equipment, and that's all there to help someone or to address any kind of problem in the equipment as soon as possible. Yeah, as mentioned before, so these gateways will be part of an analytics system. And by the way, things could be on a cloud, or depending on the customer, they could be on an on-prem computer. Doesn't all have to be on a cloud. It depends on how you decide to operate in your facility, but you could kind of choose back and forth. There are different instances where one makes sense over another. So don't want to say that everything has to be on a cloud-based, but you can also, like I said, there are on-prem solutions that would also work as well. Next slide, Robert, please. And so finally now, just to give you an example, this is what an architecture would look like. And these are all open protocols. IO Link is an open protocol, so that means anybody can make IO Link devices. Most of the Ethernet protocols used in industry are open protocols, so anybody can make those devices as well. And you can see here with a combination of distributing IO Link masters throughout a system by using Ethernet. Now you can pick up data points from all different devices all throughout your plant, whether they're temperature, vibration monitoring, pressure, flow, RFID tags might be needed for some, customized manufacturing, lot size 1 we talked about before, cylinder position, valve manifold information, smart other electric actuators. So all these devices, they may inherently have diagnostic condition monitoring information. They might be customized. So some good benefits with IO Link. It's a point-to-point connection to these individual devices, but the information is bidirectional. So you can configure a device on the field like a temperature sensor, and you can pull information from that sensor. So devices can be configured and controlled. If a device needs to be replaced, IO Link has the ability to, by using data storage, that it can send the new configuration information to that device. So you don't have to go through a difficult process of reconfiguring any one of these intelligent devices. That information could be stored in the master. It'll be dumped into the device when a new device is loaded on. And so it's very easy for replacement. You talk about in distances, cable maximum length for IO Link is 20 meters. You couple that with the maximum distance on Ethernet between devices is at 100 meters. You can really distribute these sensors throughout the equipment quite easily, and then be able to use this data for the purposes that you need to. Okay, Robert, I think that probably opens us up for another Q&A session.
Yes, it does. We're at a point now where we have another Q&A. Yes. Kristen?
Hello, we're back with some questions. Okay, first question here is, when and where is the best application for equipment or line redundancy?
Well, I will try to answer that. And I think I spoke a little bit about it earlier. I think there are instances to accommodate plant upstream product changes. So if they're strategic SKU changes that, say you're running, I'm just making this, you're running a base product, and then that same base can go into 2 different SKUs, and you add a flavor, a chocolate or a strawberry, and a beverage. So I want to keep that primary station filler running, right? And the product that I'm going to get downstream, I want to keep it moving. So a redundant piece of equipment will keep that line running, producing its base product. I see it there. I think you should be careful not to accommodate poor performing equipment or packaging systems with redundant equipment. It happens today because of the aggravation it takes to, it's just take work to redeploy that line or decommission it. It'll only be decommissioned, that line will, if it's redundant, if there's a need for some new innovation. So, and again, that redundant line is not adding a lot of value. It's an added cost, added resources, and in today's climate with technology, maybe, again, I'm going to go back to the OEMs, maybe there's an opportunity for you to have a conversation with your customer about maybe you've got some technology that can help them offset their redundancy and reduce their costs.
Excellent, thank you. Here's another one. At what point does continually fixing the old machine instead of buying a new one stop making sense?
Oh boy.
It's a big one.
Oh my goodness.
Well, I could answer that from a controls perspective. You gotta look at the current machine controls. Are they still available for replacement? you know, manufacturers, you know, have to discontinue parts simply because, you know, electronics become obsolete in them. But if the machine is isolated from a plant or something due to lack of connectivity, you want to be able to get that connected, I think, to the plant. If there are ways there, I know that there are retrofit kits that that some vendors make for some newer controllers. You can upgrade an older controller to a newer controller, which might take you from an older network or no network system at all up into to a controller that supports an Ethernet-based network. And now you've got a you know, new piece of you've got a new retrofit you got a retrofit on an older machine that's now able to be linked with other equipment or other systems. That might you know, that might work for some old system. But if you can't do that at that point, you know, then from a controls perspective, I think you're stuck then, you know.
Yeah.
Yeah.
Let me add to what Frank was saying, because this is a common challenge that companies face. I would also say that if your annual cost to maintain it exceeds a new piece of equipment purchase price, that's an easy decision. And so that would be, there's a win, right? So, and secondarily, if the throughput of the existing asset has decreased, and you can't get more out of it, and the new equipment, again, can give you more and pay for itself in a certain time frame, and be less expensive, that becomes a business decision. As Frank said, you know, if you're a smaller company, smaller food company, you know, those are different decision points you have to make. Then you would take the least aggravated cost solution first, right? You know, spend as little as you can, but be smart about it.
Thank you. Here's a general one. Why is mode of operations so important?
Oh, well, from my career in just, you know, looking at the industry, even today, forming the company that I have today, I think if you want excellence, you start off in the very beginning. And so we talk about using digital twins when we start designing and developing equipment, right? And how that plays into decreasing costs and ensuring excellence in vertical startups. I think that it just plays into you know, what we're just trying to do. It just makes sense.
Yep. I think this one's for Frank here. What types of data equipment do you find valuable on packaging equipment for maintenance purposes?
Oh, wow. Okay. So, for example, data collection equipment. So, for, you know, simple things. So, example, you might have a dancer arm that's pneumatically operated by a pressure regulator. You know, a pressure sensor might be something that's suitable for that. For data collection, monitoring data cycle counts, things like that, monitoring mileage. You know, we see the trend maybe in certain analytics to, you know, if you have a pneumatic cylinder moving back and forth with cylinder switches on each end, you know, where you would actually, you know, you could time the motion of that and trend that time from the cylinder extend command till the time it reaches its extend point, and you can trend that over a period of time and see if that's degrading. That would be a good indicator that there's some kind of wear or there's some sort of stiction happening in the cylinder, that perhaps the seal is starting to cause problems or drive or, you know, degrading, and so that would be an indicator of repair. You know, that's part of like machine learning algorithms that are really starting to come today, that I think will be deployed much more frequently in the future, to be able to look at those trends and be able to make decisions based on the sequences and trends of the machine.
Excellent. And for this last question here, we're going to pull way back and talk about, we have a question that's, we're a small company, seeing growth and looking to invest in the first piece of packaging equipment. What advice would you have and what to look for?
So can I, Robert, I'll take that one.
Sure, go ahead, Frank.
I mean, first, you know, you know, simple things, I'd say, shoot for reliability. What are design components on the machine? Look at the B10 values. B10 value is just an analysis of when 10% of a population of what any kind of component fails, and that's usually measured in number of counts or mileage or so on. And look for high reliable costs, high quality components. That might be one simple thing to do. Make sure the machine is future proof, I think, is the next thing. Being able to integrate with other machines and other certain software platforms for the reasons that we've discussed already this afternoon. You can, connecting machines together, collecting that data from the equipment. That's really, I think, quite important.
Excellent. In closing, I would like to ask Robert first to kind of give a recap on some last words, and then Frank will go to you.
Yep.
Thank you. Okay.
So when I think about, first of all, thanks for, again, FPSA inviting me to be part of this panel. It's near and dear to my heart. I think what's important today, when I look holistically in market, I look at it from two perspectives. There's the food companies and the equipment suppliers that are supplying to retailers and consumers. It's really a simple equation. And I think the conversation, we need more of a collaboration with both all these entities and what a win looks like. And as Frank is saying, there's a lot of technology out in the market, but how do you apply it? And how do you know what's best for you? And I think it's having that understanding, that conversation to help the OEM design and prepare for the future, near future, that's changing rapidly. And for that food company to communicate really what they're trying to do and have a level of trust with that OEM to deliver those systems. In my prior career working for two major CPGs, I faced that quite a bit. It was just, how do you collaborate what you're asking someone to deliver, them thoroughly understand it and deliver it on time, on budget, and maintain a vertical startup. And if we could win there, I think the whole industry will be, it'll be a win for a lot of companies. There's a lot of growth here for everyone. So let's just have more collaboration and understand each other's world.
Okay. Yeah, thank you, Robert. And then, yeah, thanks, Kristen. I just want to focus again on the idea of digitalization, being a journey. It's not just for the operation of the equipment. There are many steps that you take from the very idea of conceptualization and design, whether it's a piece of OEM equipment or a plant or production process, all the way down through to the maintenance and service of the equipment. And there are many ways that, again, I'm going to use that ARC quote, internet-enabled technologies to help you with your business strategies, help you improve your business strategies. There are many ways of using digitalization for that, and we can only touch on a few of them here in an hour. I didn't touch on mobility, for example, as another option, but that happens a lot. Is that there's a lot of stuff going on in that case as well to help, maintenance personnel work on equipment. So, just think again that journey from the beginning design stages all the way through to operation and then post sales and then support and service. There's a lot of different technologies, and again, the focus on the equipment, the Ethernet-based technologies with a subnet like IO-Link is, I think, these open protocols are, I think, a great way for collecting the data and being able to digest that and be able to really come to a quick resolution of your equipment. And these internet enabling technologies are helping players, helping users come to solutions much faster than before.
Excellent. Thank you, Robert and Frank, for your time and your insights. We really appreciate it. And I want to thank everyone for joining us. You will be receiving an email in a little bit that will have a link to the recording of this webinar where you feel free to share it with those who weren't able to join us. And also be sure to check out packagingstrategies.com for more solutions. Thank you, everyone.
Thank you. Thank you again.
Thank you again. Thanks for having us.